Assalamualaikum. My name is Muhammad Izzaquan bin Muhammad Dali. Today we will present our research about optimizing polylactic acid using Chitosan from crab shell. Before I forget, I will introduce to my group members. There we have Nakiuddin, Amar, Danish and myself Izzaquan.
Assalamualaikum. For the abstract part, the compression molding technique was used to create polylactic acid (PLA) metallic composite reinforced with Chitosan microparticles. Chitosan particles were created chemically from crab shell through deproteinization, demineralization, and decatylation process. The dynamic light scattering particle such analyzer, Fourier transform infrared spectrometer (FTIR), X-ray diffractometer (XDR), and scanning electron microscope (SEM) were used to determine the size, functional group, structure, and morphology of the Chitosan microparticle. PLA and various weight fraction 2, 4, 6, 8, and 10% of Chitosan particles were blend for 10 minutes in arcade polylab OS ceramic batch mixture set to 60 rpm and 162 degrees Celsius. The blend was then formed into various test specimens using a carrier laboratory press at 190 degrees Celsius for 12 minutes under a applied pressure of 0.2 kPa. The developed composite mechanical properties and wear behavior were investigated. The result revealed that the mechanical and wear properties of the developed PLA metallic composite have improved. The optimum value for mechanical properties were found to be 6% Chitosan particle reinforcement and 10% were resistant. The scanning electron microscopy examination of the composite revealed that particles were distributed uniformly at lower weight fraction, while the particle clusters on the same image at higher weight fraction.
For introduction, I will be the presenter. First and foremost, for polylactic acid or PLA is a biodegradable polymer that has been used widely in various industrial fields owing to its biocompatibility, high Young's modulus, and high tensile strength. In biomedical fields, it is used as cardiovascular implants, dental niches, drug carriers, and many more. However, polylactic acid still has a limited, which is in terms of biodegradability and hydrophobicity. Next, crab shell can be synthesized to get the Chitosan. For your information, crab shell is one of the organic wastes that nobody cares about it. There are a billion of tons of the crab shell that idle around the world. Nowadays, many researchers do the research and discovered an essential biomaterial from the synthesis of the crab shell, such as Chitosan. In order to get the Chitosan particles, the crab shell will chemically be synthesized by deproteinization, demineralization, and deacetylation process. Then, Chitosan can be used to optimize the polylactic acid metal composite. To optimize it, the polylactic acid and Chitosan were blended together with the mixture. Then the blends were molded in different specimens using cover laboratory press for 12 minutes at 190 degrees Celsius, while the pressure is 0.2 kPa. That's all from me about the introduction. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Next, I will proceed to our methodology. In our study, we use 8 materials. We use an average particle size of 3.2 micrometer of Chitosan. We use hydrochloric acid, sodium hydroxide solution, and silicone oil and deoxyl fatalates. The crab shell was obtained from a Lagos, Nigeria seafood restaurant. We use a 4% weight average of a D-isomer content. A molecular weight we use at 235 kg per mole. Density we use a 1.24 gram per centimeter. We use a glass transposition temperature at 16 degrees Celsius. Melting point temperature we use at 175 degrees Celsius. The size of Chitosan particles was determined by analysis the dynamic light scattering particle size. The particle size of the powder was analyzed by using FTIR spectroscopy, Fourier transform infrared, and Auriga scanning electron microscopy to scan electron microscopy energy. All of the methods are summarized in table below.
Assalamualaikum warahmatullahi wabarakatuh. Now I will present our result and discussion. There are three main result and discussion in our research. First, size analysis of the Chitosan particle. Second, FTIR analysis of the Chitosan particle. And the third one is the interpretation of the FTIR spectra. Okay, for the first one, figure 1 shows the particle size distribution of Chitosan particle. At 3.2 micron diameter, a broad single peak present in the particle size distribution. This shows the maximum size of the Chitosan particle. The second one, figure 2 displays the FTIR examination of Chitosan microparticles. The FTIR spectra were interpreted to look for and also identify all potential and main functional group that might be present in the Chitosan microparticles. In table 2, all the functional group that present during the synthesis of the Chitosan particle have been identified by peaks from the interpretation of the FTIR spectra, hydroxyl group, carbonyl group, and amide group present.
And last but not least is our conclusion. In our conclusion, we can conclude that Chitosan particles can improve polylactic acids and were extracted for use in composite manufacturing. The chemical process of the chitin diacetylation was shown to be efficient and effective. In terms of mechanical qualities, the resultant composites outperforms the Uriforce PLA matrix or polylactic acids matrix. The purpose of this project was to encourage the use of natural material such as our study is a crab shell. That's all from our group. Thank you.